you know what, maybe I'll just start and we'll see how we go. Maybe we can bring it in later. There's not too much to display anyway. It's mostly listening to my voice. So I work at Kablamo. I'm a tech principal. I specialize predominantly in doing data and search engines. We're a digital product company, so we do things from AWS all the way up to finding out what you want to build, all that sort of stuff. Talker suggests processing 40 terabytes of code from 10 million projects on a dedicated server using Go for $100. So I'm going to go through all of the reasons I did this stuff. I didn't have a plan to begin with. I would probably do things differently if I was to start today. And what I'm going to do is I'm going to go through, what I was trying to do, the iterations of what I was actually doing, and I'll throw in some of the interesting data tidbits that I came across as I go through it. And I was going to show up here, I was going to do my bragging slide where I'm like, oh, these are my data sets. So the biggest sort of data set I've ever worked on is 6 petabytes. I'm sure there's people out here who laugh at that, thinks I could do that for lunch. The largest amount of rows was something like 2 trillion when I left the company. That was growing by 250 million a day, so that was quite fun. And the highest queries per second I've ever dealt with was 70,000 a second under a DDoS attack because we annoyed Russia somehow. And the title is completely clickbait. I say 10 million projects. I was actually short by 15,000, please forgive me. So yeah, as I said, it's a newish format for me. I normally do talk slightly differently, but in this case, I'm going to walk through what I'm actually doing. So I'm going to go through what I did, what failed, what did I learn, mix in the findings that I've got, and throw in my future thoughts and things that I'd like to try in the future. And so as I mentioned, why do I do this? I get asked this a lot by my managers. So they often ask me, why do you do anything? And as I said, I don't really have a good reason for a lot of things that I do. I'm usually just doing it to have fun. I think that's kind of the main point of doing stuff. So a lot of this was organic, and you can see that there's definitely mistakes that I made as I was going along with it. I still got an answer, but I'm not too fast. My main driver for doing this sort of thing was reducing cost. And I write a lot of code outside of work. And I know that's not really a why did I actually go and analyze this much code. I will give you that. I have 2 good reasons for it. So I maintain a lot of code outside and projects outside of work. One of them is called Slot, Clock, and Code. I don't know if anybody's heard of it. It's called SCC. It's a command line tool. What you do is you run it inside a code repository, and it will quickly scan through it and count all of the code, all of the comments, all of the lines, and it spits it out for you and says you've got this much Go or you've got this much Java, and it'll tell you the biggest file sizes if you want. And one of the things that I added to it, because no other tool did this, was an estimate to determine how complex a piece of code is. And if people here do Visual Studio, are probably aware of cyclomatic complexity. It's kind of like that. It's an approximated version of it. The problem with it is that a lot of people were asking me, what does this number actually mean? Because, I run it on a project, I get a complexity of 200. Is that good? Is that bad? I don't know. So I thought, why don't I just start running this across a whole bunch of different repositories? So I checked out, things like Redis, Lucene, the Linux kernel, and I started running it and collecting the results. And I was, this was taking a long time, and I realized, I'm not going to get every language it supports because it supports 240-something languages. I'm not getting different repository sizes. I need to expand my mind on this one. So it turns out, luckily enough, one of the other projects I maintain is a site called searchcode.com, which, as the name would suggest, searches code. I'm not very original when it comes to names. And at the time, it was aware of about 10 million projects across GitLab, Bitbucket, GitHub, Coplex, a few. So my idea was I'll export all 10 million of them, and then I'll use those to feed into SCC to count, and then I would have a good data set in order for people to say, oh yeah, that makes sense, that kind of fits in where I'm going. It's aware of about 40 million in the future. So my first attempt when I was doing this is I ran it on my desktop. Now I have a pretty old desktop at home. I think it's like 10 years old at this point. But it was good enough for something like this. So I wrote a simple shell script that basically just went through each repository, checked out the code, and then ran SCC across it, and I started saving the results to disk. One of the ways that SCC works is you can pipe the results out into JSON. So I started saving them on disk. And this was back when NBN was sort of still rolling out. For me, I had a fantastic ADSL2 connection. It was like 21 megabits most of the time. It never went down. NBN came by, installed the node. They didn't connect me, but they did drop my speed from 20 down to 3. So as a result of this process started consuming all the bandwidth, and this resulted in complaints from the children because, hey, Netflix and YouTube aren't working, which resulted in complaints from the wife. And the first rule of marriage is don't annoy your partner, so I decided I need to come up with a better way to do this. So and this would be with a slate. So the first kind of interesting finding that I got out of the data set once I actually started crunching it was, what are the most common file names? And if you'd asked me beforehand, I would have said readme, main, index, license, stuff like that. That's actually what I got. There were some really interesting findings in there. I found a file that was really common across a lot of languages, projects, is 15 and S15. Now, I have no idea why so many file names are called 15 in all these different projects. S15, as it turns out, is used in a lot of JavaScript projects for a thing called Font Awesome, where they're storing a image of a bathtub in that for whatever reason. The other one that I found that was really interesting is jQuery was super high on the list. So, you know, the reports of its death greatly exaggerated, in my opinion. Now, at Kablamo, I work with AWS a lot. We're AWS partners. We build a lot of it. We advocate a lot for things like Lambda. Quite happy to use it. And I'm sure most people know serverless has got a lot going for it. You've got your low cost. You don't have to really worry about the infrastructure and whatnot. So I actually had set it up previously to analyze code. And I was doing that, you know those shield things that you get? Oh, is that me? That is me. All right, now you can actually see stuff. I'll go back to the previous one just quickly. Most common file names. As I said, jQuery is very high on the list. The 60 million make files kind of shocked me though. So yeah, this was what I did with AWS. So those shield things at the bottom are things that you can like add to your GitHub repository, so you can say how many lines of code, comment when like I implemented this really quickly. It's using API gateway, talking to a Lambda, saving the results in S3, and then it's serving it back out. So my first attempt was I'll get this Python script and I'll go through all the repositories and I'll start pumping them into the API gateway and the Lambda and I'll get the results. Great, they're all saved into the bucket. This is reasonably clean from a developer perspective. It was kind of really easy to run. The problem is that, well, there's a few problems. One problem is that when Lambdas are set up like this, they have a 29-second hard timeout limit, so it didn't work for things like the Linux kernel and certain Apache projects, which is probably okay. I could have run that manually. The other one is that I ran this for about 1 million repositories, and I ended up seeing my AWS bill was going to be $60 for that. I went, I don't want to pay $700 for just a little bit of fun. So I think I need to think of another plan. And I should mention, I hadn't even got to the point of analyzing it then. So we were just running, collecting the information. So this is another finding. I was curious to see how many pure projects, a pure project definition being slightly fuzzy, but let's assume that there's just a few languages in a repository. I defined it as sort of 5. If you've got 5, because that includes your README, your license file, your git ignore, stuff like that. Turns out most projects are pure for some definition of purity. And what I did find interesting about this one, there is this odd bump, like suspicious bump, which you can see there for projects that have 34 to 35 languages. Why this is? No idea. If somebody can answer that to me, I would love to know. It's one of those great unsolved mysteries. So this was attempt 3. So I'm already in AWS, right? So the HIP solution is let's just dump them into an SQS queue, and then we can have things read off said queue, process them, and put them into S3. And you know, I mentioned this to the Brains Trust at work on the Kablamo Slack, and they were like, yeah, that's good. And I'm like, yeah, cool, I can do that. And so I was like, okay, I started thinking about this, and then I started thinking, all right, I've got a way to get this really quickly now. I now need to analyze it. And I started going, oh, well, I could use Athena. Athena over S3, it's serverless, it's great, right? Thankfully, at the time, I was doing a work project where we were using Athena. And I had great fun pressing that button, and it was costing 50 cents for every query that I was running. I then calculated against this based on the data that's it's like $2.50 per query. I was like, that's not going to work. And as I said, it was in JSON. It could have been more optimal to reduce the cost, but then I've got to pull it out and analyze it. It was already working. So I went, no, I'm not doing this. And the other thing is, I've got to do DevOps to actually stand this up properly. I mean, yeah, I don't mind doing DevOps. I don't want to do ClickOps through the console. Too much work. I'm feeling lazy. Let's come up with another way. On the subject of DevOps, there was a big argument on the Kablamo Slack over should we use YAML or YML. I'm not going to say which side I'm on. It was a lot of people dying on one or the other hill, like serious death and destruction to the other team. So I thought I'd just calculate it and get the winning side. Yes, I won, I was happy. I think it's just something that's easy to bike shed about, so everyone, has an opinion. So attempt 4. So to paraphrase the infamous MongoDB is web scale video. As architects and developers, we have this tendency to read sites like high scalability and think that we've got Google problems and we're Google architects. And there's a great post out there that sort of talks about this called Taco Bell programming. The core thesis is that you can solve nearly every problem using eight ingredients. So the reason being, Taco Bell makes billions of dollars using 8 ingredients in different ways. Just use Unix pipes, use sed, script it all together. It's actually really, really easy. And they've got this great example of, I don't know if you can see, oh yeah, it's down the bottom there, of a 32 process web crawler that's just like a simple line. Yeah, pretty easy. I don't subscribe entirely to this, mostly because I'm not very good at sed, but as the keynotes were saying, the Google MapReduce paper came out in 2014. Hadoop came out, a few years after that. That's 16 years ago. Machines are pretty powerful these days. And for me, Search Code had multiple servers, and it was fronted by a Varnish server. I don't know if anybody's familiar with Varnish. It's a HTTP cache accelerator. It uses no CPU, it's all RAM. And that box, as a consequence, was doing the square root of 0 for most of the time. So I thought, why don't I just run it on there? So what I did is I wrote a very simple Go program that replicated the Python stuff that I'd done. And it spawned 32 processes, and it just called out within those processes to call git and then SCC, collect the results and save it. So I was using a box that I just had lying around, I was already paying for, but I was curious, how cheap could you do this? Now I'm in Hetzner, that's my preference for these sort of things because they give you fairly cheap and expensive. I went and had a look just to see. They've actually got a deal at the moment. If you want to do something like this, you can get a brand new server for 44 euros. I know the exchange rate isn't great right now. At the time I did this, that was fantastic. It was nearly equivalent. And if you want to get even cheaper, you can go and fiddle around on their server auction where you can find these boxes that are incredibly powerful for super cheap discounts. There's no setup fees. Really, really do recommend those guys. So this is a HTOP capture of what was going on the box. You can see the git clones in there. You can see the process. Once again, I said I'm bad at names. I imaginatively called it a process. And you can see Varnish down the bottom doing nothing. This is what the box looked like most of the time. It's not CPU bound. The load average is high because it's basically network. It's all waiting on those git processes to come down. So I said, I did it in Go. Initially, I wrote it in Python, and I kind of have some rules about Python. I'm a big fan of Python. It's just, it's pseudocode that you indent and run, and it works. It's fantastic. But I didn't want to install the dependencies on my nice, clean Varnish box. And I kind of have a rule that if you have to import something that's not in the standard library, if you're going to run it sort of more than 5 times, or if it's going to take more than a few hours to run, I rewrite it in Go. Simply because you get that the concurrency in it, which is really nice, and you get a binary that you can deploy. So I basically ported it straight to Go. Fantastic. And going back to the Taco Bell programming, there's a nice analogy between how Go works and Go's channels work and pipes work within Unix. It really is a very, very close mapping. So these are sort of equivalent to what they're doing. We've got a nice shell script that's basically printing out all of the lines of our URLs that we want to go get, and then it's spawning, using XHards, it's spawning 16 processes to run Python across them. The Go things down the bottom, fairly similar. It's got a few advantages though, because while I've defined it to use strings, I could change that to a real type, and I could put other information in there. I can pipe it back out if I want to. I can do other things. It's just a little bit easier to work with. Here's another one. How many files are in the average repository? I had no idea going in. It turns out, by lumping them in buckets, that it's sort of around 200. This is down to the 95th percentile. If I put the whole thing on there, this graph just turns out to be a thin smear on the left. Most of them have less than 300, and 85% have less than 200. So your project is probably fairly equivalent. Apparently 200 files in a project is fairly normalish. Now, obviously this is skewed by outliers, but it jumped into the buckets. Seems fairly normal to me. Then I got to the processing. So how do you process, 10 million JSON files, which at the time took 1 terabyte of space in an S3 bucket. So I'd already ruled out Athena. That's too expensive. As I said, it's in JSON because that's what the tool spits out. And so I really didn't want to reprocess it. So I thought, oh, what can I do here? So the brains trusted work said, oh, dump it into a SQL database. And that would be fine, except the box that I was running it on, a spare compute, it had a spinning Rust disk. I don't think 1 terabyte on that disk was going to be a terribly nice experience. So I thought, well, what else could I do? What I'll do is I'll pull all the files down once out of S3, which is something I wish I hadn't done because I wouldn't have had to pay those egress costs, and I shoved them into a big tar file. It made it really easy to process after that. So I did that once, fantastic. And then I was like, well, how am I going to process it? And I went, well, I know Go. I've already written Go to do all the other stuff. I'll just keep using Go. So I basically wrote a script that looks like this. It's fairly horrible. I had worked out all of the things I wanted answered up front. And the reason I did that like this is I was like, well, I can just process it once using the Go rather than having to convert it into SQL or some other data format. And, I could just loop through. All is fantastic and happy days. The other thing that this was kind of useful for is I was able to do things that wouldn't be easy in native SQL or a lot of other query formats. And one of the examples we'll get to is which developers have the worst potty mouths is an example of that. This is another one that came up on the Kablamo Slack when we were working with a Java project. So, we've all heard of, Java factories, Java factories. I just thought, let's see, are there any actual factories out there? Alas, there are not. I was very disappointed with that. But it turns out 2% of, Java code, just a bit over, is factories or factories. That said, I am convinced there is a non-ironic factory out there that makes more money every day processing stuff than I will ever see in my life. So if you know of one, please let me know. I'd love to add a one there. That would be fantastic. So these are the raw numbers of what it ended up actually doing. As I said, it was 15,000 less than 10 million repositories. Please don't hunt me down. I'm sorry. About 1 million of them nearly were empty. That really surprised me. A lot of files. As you can see, it worked out to be 40 terabytes of code that I processed. That shocked me. It was extremely shocking. And particularly in the keynote when they were saying one of the data sets was like 10 terabytes or something of GitHub code. I was like, no, there's more than that. I know that for a fact. It took about 5 weeks to clone all of this stuff. I was doing Git shallow clones. And that worked out to be, given the 5 weeks, it's about 3 million seconds. So it's about 3 a second that it was processing. It was really going quite well and saturating its bandwidth. The actual crunching of it, the 1 terabyte of files, took 49 hours using Go. I wrote that to be single-threaded simply because it turned out that it was bound by disk, and that's because it was running on spinning Rust. But these are all the things that I got out of it, and I've got all of this information for all the individual repositories. Great, I can do something with that. Unfortunately, I never did. I'll get around to that one day. So potty mouths. So this was what I was saying. This is one of the things that I could do because I was writing Go code. I was trying to work out, which developers curse the most. And I know this falls into NLP problems of, is this a swear or not? I just basically took a whole massive list and then I did some leet speak translation of it to see if I could get it. My first thought when I saw this was naughty C developers. They're very naughty. But it turns out that there is a serious outlier on the chart, which is Dart. Is anybody here a Dart developer? No. Okay, if you know somebody who's a Dart developer, you might want to go offer them a hug. Why are they more than 2 deviations? I have no idea. I feel sorry for them. They've got issues, apparently. So yes, please offer them a hug if you can. Lessons learned from this. So there's quite a few up here. So has anybody ever thought, storing lots of files in the temp directory on Linux is a good idea? Handy tip, no it is not. You think it's a good idea because if I reboot the box, it just deletes everything. Yes, but if you ever actually tried that, 5 minutes? 5 minutes. Oh, I'll be no problem. The reason is on the startup process, the whole machine halts while it's trying to clear those. If you dump millions of files, as I did, it halts for a long time. I ended up having to boot into recovery mode and then find what's the fastest way to delete all these files, which is this horrible, bizarre command that I can't understand. I still can't understand today, in order to fix it. And that's how search code actually went down for the better part of a day. Other things I'd say is don't use S3 at first until you think you really need it. As I said, this was just a one-off thing. I probably shouldn't have used it. Use compression. CSTD is probably where I would go for these sort of things. I know that gzip is ubiquitous. Use that. Great. when you're using things that use lots of CPU for a long period of time, like this was, I think dedicated's the way to go. It's infinitely cheaper. Use depth 01 for shallow get clones if you're doing this sort of stuff. And I found out that Go works surprisingly well as glue code. So for pretty much everything I do now, I don't write any Python. Go works almost as well. And as I said, it fits in that definition of I'm not using libraries in it. This is the biggest one for me though. Dedicated servers are stupidly powerful. Like I had a look at Hetzner again last night, and you can get for like 300 euros a month an 80-core ARM machine with 256 gig of RAM. You can get a 32-core AMD machine with a terabyte of RAM for 500 euros a month. AMD makes CPUs now that have 1 gigabyte of level 3 cache. Like that is just unbelievable. Most people's data sets are less than that. And you can put that on the chip itself. That is insane. So yeah, if you're doing stuff for long periods of time, try a dedicated server out. It might surprise you. So for any talk I attend, I like to get a single thing out of it that is, oh, I learned something today. This is the one I would hope you get. This is flawed. I was basically looking for things that have got, license, copying 3, unlicensed, license MIT, just common licenses. It's missing things like readmes or SPDX. But this still represents a problem to me because it's saying that a lot of repositories don't have a license. Now, I have heard a lot of people say, oh, it hasn't got a license, therefore it's considered public domain. Okay, I've got 2 big issues with that. 1, that's not true. You have to explicitly say it's public domain. 2, I'm guessing most people here have an Australian citizenship. Anybody with a German citizenship? No, okay. So, Australian and German citizens are not allowed to give up their human rights, and copyright is defined as a human right. So, as an Australian citizen, you cannot put anything into public domain because you cannot give up your copyright. If you want to do this, you have to pick an appropriate license. MIT are unlicensed. And you're probably wondering, why does this law exist? I'll give you a hint. Germany added this after 1945. So it's there for a good reason. License your stuff appropriately. I have seen people who've gone, oh, I'm in big trouble trying to put things in public domain. You can't do it. I plan on doing this again sometime in the future. I mean, I'm not going to go too deeply into these. I'd like to try SQLite. That seems to be the flavor of the month on Hacker News. I think that would be a great blog post and I could get them all angry at me. I'd like to use the latest version of SCC. I'd love to have a formula for determining maintainability. If somebody knows one, I would like to hear about that. I've read a lot of academic papers. There's various other stuff in there. Maybe I'd try it with Zig, Rust, something or other. Throw in some vector comparisons. One thing I would like to do is actually keep the data around for a long period of time and throw it into some sort of a vector database so you could run it on your code and go, show me similar projects. I think that would be very interesting. Possibly another talk for here next year. Thank you very much. All of this stuff is on here, like everything. If you want to take a screenshot of a slide, this is the one to get. Otherwise, go to my blog. I will link it up probably today. I appreciate you coming here. As I said, I would have been in the LLM talk. If you've got any questions, come and talk to me. I have lots of swag and I'm not carrying it back to the office. So come and get it. There's lots of interesting t-shirts and bags and stuff. And yeah, otherwise talk to me anytime. I'm pretty friendly. I don't bite. Thank you very much.